So now we're going to look at the restatement of our rule for adding two numbers with opposite sign. Let's look at that together. When we add two numbers of opposite sign, the absolute value of the sum is the difference of the absolute values of the numbers being added, the smaller absolute value being subtracted from the larger. And the sign of the sum will be the sign of that of the two numbers being added, which has greater absolute value. Okay? So let's apply that to this relatively straightforward example, and let's look at it carefully, okay? So the example is going to be, what is 100 plus negative 104? First of all, is this the rule to apply? Yes. When we add two numbers of opposite sign, these are of opposite sign. So we're going to apply this rule. The first thing the rule tells us is what the absolute value of the sum is, right? So let's find that out. So let's look at this rule one more time. The absolute value of the sum is the difference of the absolute values of the numbers being added, the smaller absolute value being subtracted from the larger. So we know that 100, okay, has absolute value 100, right? And negative 104 has absolute value, okay, 104. We ask ourselves, which one of these is bigger? Okay. We look at the rule again. The absolute value of the sum is the difference of the absolute values of the numbers being added, the smaller absolute value being subtracted from the larger. So which one of these is bigger? The 104. So I'm going to subtract the absolute values, the smaller one, 100, being subtracted from the larger one, the 104. In other words, 104 minus 100. 4 minus 0 is 4. 0 minus 0 is 0. 1 minus 1 is 0. And of course, you can just see that that's just 4, right? Okay. So the absolute value of the sum is 4. Now to the next part of the question, which is, what is the sign of the sum? The sign of the sum will be the sign of that of the two numbers being added, which has greater absolute value. Okay. The 100 has absolute value 100. The negative 104 has absolute value 104. If I look at the absolute values, the 104 is greater, and it corresponds to the number that's being added, negative 104, and so it's this sign that the sum will take on. So the sign of the sum will be negative. Okay. So now I can combine these two parts to get our result over here. Negative 4. Now, by the way, I want to make sure you guys understand something here. I'm breaking up these calculations into these two parts and displaying them in explicit detail here, just as a run of you guys learning how to do this. Once you guys have done a few examples yourself and have internalized this process, you won't have to be doing it like this unless you want to, right? You'll get an intuition of whether a sum will be positive, whether it will be negative, and so on. Okay, but I want to show you this way so you can ingrain how to apply this rule to real practical problems. Okay, so that's this first example. Now let's do another example together. So here, let's look at this example. 67 plus negative 37. Does this rule apply? Yes. Why? Because we're adding two numbers of opposite sign. Okay? So what are we going to have to do? So first, let's look at our rule again. The absolute value of the sum is the difference of the absolute values of the numbers being added. The smaller absolute value being subtracted from the larger. Okay? So first of all, let's look at the absolute values here. So we know that 67 has absolute value 67, obviously, and negative 37 has absolute value 37. Okay, so now how do I get the absolute value of the sum? It'll be the difference of the absolute values of the numbers being added, the smaller absolute value being subtracted from the larger. In this case, it'll be 67 minus 37. So let's do that here. 67 minus 37. 7 minus 7 is 0. 6 minus 3 is 3. So the absolute value of the sum will be 30. What is the sign of the sum? And the sign of the sum will be the sign of that of the two numbers being added, which has greater absolute value. If I look at these two numbers, the 67 has absolute value 67. The negative 37 has absolute value 37. Of these two absolute values, it's this one that has the bigger absolute value. And since it is positive, the sign of the sum will be positive. Okay? So our answer will be positive 30, or we can just write it as 30. Okay? Okay. So that's our second example. So now we're going to look at another example. Okay? So here, we're going to look at this example here. What is negative 1/2 plus 3/4? First of all, does this rule apply? Does this rule apply when we add two numbers of opposite sign? Negative 1/2, positive, and 3/4, we're adding two numbers of opposite sign, so the rule applies. So now the question is, what are we going to do? Well, first, we have to find in order to get the sum is the difference of the absolute values of the numbers being added, the smaller absolute value being subtracted from the larger. So the first thing we're going to do is we're going to find out the absolute values of these numbers. Okay? We know that the absolute value of negative 1/2, negative 1 has absolute value. By the way, I'm sorry for abbreviating. I'm just trying to save space and also save time. Negative 1/2 has absolute value 1/2. Okay? And 3/4 has absolute value 3/4. Okay? So now we're facing a problem. Obviously, I know that probably all of you know which one's bigger or smaller than the other, but let's pretend we didn't for a moment, right? We're faced with a problem. In order to calculate the absolute value of the sum, we need to find out which one of these absolute values is bigger so that we can subtract from that bigger fraction the smaller fraction, right? In this case, since they're fractions. And moreover, we have to know which one's bigger because we have to figure out which one's bigger to figure out which one, what the sign of the sum will be. Okay? So how do we do that? Let's do that here. Now again, I'm just going to take the absolute values for this moment. Okay? So 1/2 and 3/4. And I want to ask myself the following question. Is there a number which is a multiple of 2 and which is a multiple of 4 that they have in common? Aha! 4. If I multiply 2 times 2, I get 4. If I multiply 4 times 1, I get 4. So that will be our common, that will be the denominator we want to make equivalent fractions. Or let me restate that. Because we know that 4 is a multiple of 2 and a multiple of 4, we will aim to get equivalent fractions to these given fractions that has equivalent fractions that have the denominator 4. This one already has denominator 4, so we're not going to have to do anything to it. We are going to have to multiply this by a fraction that equals 1 in order to make an equivalent fraction that has denominator 4. So let's do that together. I'm going to multiply it by, what times 2 is 4? 2. So I have to multiply the top and bottom of this one by 2. And so that'll give me 2 times 1 is 2. 2 times 2 is 4. Okay? So now I know that 1/2 is equal to 2/4. But now I can compare these. Which one is bigger? This one. Because since they're over the same denominator, the one that has the greater numerator is the one that is bigger. Moreover, now that I've gotten them on the same denominator, I will be able to easily subtract them. So first of all, what will be the absolute value of the sum? The absolute value of the sum will be the difference of the absolute values, but where the smaller absolute value is subtracted from the larger. In other words, it'll be, now that we know that 3/4 is bigger, it'll be 3/4 minus 1/2. But we just saw from what we did here that that's the same as saying 3/4 minus 2/4. Okay? And now, how do we subtract fractions with the same denominator? We subtract the numerators and keep the denominator. What is 3 minus 2? 1/4. Okay? So now we know the absolute value of the sum, 1/4. And now we need to ask, what is the sign of the sum? So the sign of the sum, okay, will be the sign of that of the two numbers being added, which has greater absolute value. These two numbers that are being added have absolute values 1/2 and 3/4 respectively. We saw here that the 3/4 is the one that is greater, or the 3/4 is the greater of the absolute values, and it corresponds to the positive of the two numbers being added, and so the sign of the sum will be positive. So I can write the solution here as 1/4. Okay. So now let's look at another example, and then we will move forward. Thank you. So now we're going to look at this example. Okay. The question is, what is 2/9 plus -3/5? Okay, that's the question. The first thing we want to know is, does this rule apply when we add two numbers of opposite sign? Yes, this rule applies. The absolute value of the sum is the difference of the absolute values of the numbers that are being added, the smaller absolute value being subtracted from the larger. So the first thing we have to do here is we have to find out what are the absolute values of these two numbers that are being added. Okay, we know that 2 9s, right, has absolute value 2 9s, right? And moreover, we know that -3/5 has absolute value 3/5. Now, obviously, from the previous example, you already know what we're going to have to do. We're going to have to find fractions that are equivalent to these, but which have the same denominator, so that we can, first of all, compare them, so that we can figure out which to subtract from which to get the absolute value of the sum, and then, of course, which of these absolute values is bigger, so we can figure out what sign to assign to the sum, right? So let's do that together. So over here I have 2/9 equals to 2/9 times some fraction that is yet to be determined. And we have 3/5, right? 3/5 is equal to some fraction, is equal to 3/5 times some fraction that is yet to be determined, to give us our equivalent fractions to perform the comparison. So in order to do that, we have to ask ourselves in our brain, is there a number that is a multiple of 9 and which is a multiple of 5? What's the smallest of those possible multiples? 45, right? 9 times 5 is 45. 5 times 9 is 45. And from what I just showed you, you can see that, that means I'm going to have to multiply this fraction by 5/5. Okay, and I'm going to have to multiply this fraction by 9/9. This side will give me 10. 2 times 5 is 10/45. Okay. And then 3 times 9, that's 27/45. Oh my God, this got so cluttered, I apologize. So that means, if you look at this, that means that the 2/9 is less than the 3/5. Okay. I'm sorry that got so congested there. Let me see if you guys can see it. Okay, it looks good. So now we can find out what is the absolute value of the sum. Well, the absolute value of the sum will be the difference of the absolute values of the numbers being added, the smaller being subtracted from the larger. In other words, since these are the absolute values, and since the 3/5 is bigger than the 2 9s, what we need to do to get the absolute value of the sum is we're going to subtract from 3/5 the 2 9s. Okay? From our calculations here, we can see that 2 9s is equal to 10/45, and we can see that 3/5 is equal to 27/45. So let us do that here. 27/45 minus 10/45. Once we have two fractions over the same denominator, when we perform the subtraction, we subtract the numerators and keep the denominator. 27 minus 10 is 17. And then, of course, we keep the 45, like this. Like this. Okay, so what is the absolute value of the sum? 17/45. Okay. Now, what is the sign of the sum? The sign of the sum will be the sign of that of the two numbers being added, which has greater absolute value. These are the two numbers being added, and they have these absolute values. We saw that 3/5 is the greater absolute value. The sign of the number that is being added, which has that absolute value, is the -3/5. So therefore, the sign of the sum will be negative. So in this case, we can see that the result of this sum is negative 17 over 45. And I think you can see in this example and in the previous example that to try and draw a number line for these cases, although feasible, would be extremely labor intensive and impractical. However, the utilization of these rules that have been rewritten using standard terminology allows us to pursue a problem like this, the adding of two numbers of opposite sign that are fractions, with ease, with precision, and we're gonna of course need this in our further study of algebra. Okay, I hope you've enjoyed this, and I look forward to seeing you again soon. Thank you so much.